Hello friends, in this lecture I will discuss one of the important engineering function in Laplace transform technique, that is your unit step function, and otherwise called Heaviside function. So first, the definition, how it is defined, that is it is denoted by ut minus a, u of t minus a, and it is 0 if t less than a and 1 if t greater than a. That means if I represent graphically, then when it is less than a, then if it is axis t and it is axis ut minus a, then if t, the value of t is less than a, then it will be 0. ut minus a is 0, and when it is greater than a, means at a there is a jump of size 1. Okay, so there is a jump of size 1, and when it is greater than a, then the value is 1. So at t equal to a, it is remain undefined. So therefore, so that's why, and here this value a is a positive number which is greater than or equal to 0. It may be 0 also. So that's why in this way the unit step function is defined, and graphically you can represent like this. Now if I take the special value once, or the special function of this ut minus a, when a equal to 0, then it will be what? Ut only, because a equal to 0, then it will be ut only, and the value will be what? 0, 0 if t less than, here a equal to 0, so that's why ut equal to 0 if t less than 0 and 1 if t greater than 0. Okay, so it's one of the special function of this ut minus a. Now you can also represent this ut graphically, that when here a equal to 0, so that's why when t less than 0, then the value is 0. Now I can represent like this here, and here at 0 there is a jump 1, and at 1 means when t greater than 0, the value is 1. When t greater than 0, the value is 1, and when t less than 0, the value is 0. Right? So this is the definition of unit step function, and you can check here. Unit step function is an engineering function which is made to measure for engineering applications, and which involve functions that are either off or on. This is one of the very important applications when it is used. When a function is off or on, we can check in the latter examples how it represents off or on, and how to use this unit step function, and how we can use this by multiplying this function f of t with this unit step function. We can produce all sorts of effects. That type of off or on, we can produce the off and on effect by multiplying ut minus a with the function f of t. Right? Now you can check f of t equal to 5 sin t. If I consider f of t equal to 5 sin t, then the figure will be like this. Already you know that at the maximum value of sin t is plus 1 and minus 1. So since 5 is multiplied, so therefore the value will be, maximum value is 5 and minimum value is minus 5. So it's starting from 0. So 0 to 5, then it will be decreasing gradually. Then again at pi it is 0, at 2 pi it is 0. We know that. So this is our original function. So if we multiply, so how means this figure is to describe the impact of unit step function, to represent how it gives switched off and switched on, is not it? So if I multiply this ut minus 2 if I multiply ut minus 2 with the original function 5 sin t f of t, that means this figure represents f of t ut minus 2. So f of t means your 5 sin t. So 5 sin t into ut minus 2. So how it look like this. So what this dotted line represents. So check here, 5 sin t, f of t equal to 5 sin. So figure is same, but since we multiply ut minus 2 according to the definition of ut minus 2, according to definition of ut minus 2, we know that ut minus 2 will be 0 if t less than 2 and 1 if t greater than 2, isn't it? So that's why when t less than 2, the value of this multiplication, the value of this function will be 0. When t less than 2, the value will be 0. And it is again 1, the value of ut minus 2 is 1, so the value is only f of t. So that represents this figure. Same like this. So for before 2, when t less than 2, the value is 0. So that represents, this dotted line represents, it's a switched off. It is switched off. And on beginning, it is switched on beginning at t equal to 2. Isn't it? At t equal to 2 and beginning at t equal to 2, it is again switched on. Before t less than 2, it is switched off. This dotted line represents switched off. Clear? So by multiplying ut minus 2 with f of t, we can produce switched off and switched on. Clear? Now similarly in this figure C, that is we multiply ut minus 2 with f of t minus 2. F of t minus 2 means f of t is 5 sin t. So f of t minus 2 will be what? 5 sin t minus 2. So since sin t minus 2, so it will be what? When t equal to 2, the value will be 0. So that's why the figure will be like this. So what it represents? It represents it will start 2 seconds later. It will start 2 seconds, means before 2 it will be 0 because ut minus 2. So when t less than 2, it will be 0. When t greater than 2, the value will be only f of t minus 2 because ut minus 2 is equal to 1 when t greater than 2. So when t greater than 2, it is 1, and f of t minus 2 is into 1 is only f of t minus 2, and when t less than 2, the value whole value will be 0. So what it represents, f of t minus 2, it will be shifted by 2 seconds. It will be shifted, means it is shifted, it is 0 here, it is starting from 0 here, but when we take f of t minus 2 with ut minus 2, it will be shifted by 2 seconds. So it will start 2 seconds later, and it will grow in a similar fashion as in figure A. It will grow in similar fashion. Clear? So this figure represents shifting. It is a shifted by 2 seconds. It is shifted by 2 seconds. And this figure represents what? Switched off and on. Before 2 it is switched off, after 2 it is switched on. Clear? Now we will derive what is Laplace transform of this ut minus a unit step function. What is the Laplace transform of unit step function? So according to the definition of Laplace transform, we know that integration from 0 to infinity e to the power minus st, and since f of t is the unit step function, so we multiply ut minus a into dt. And since it is defined by ut minus a mane t less than a it is 0, t greater than a it is 1. So that's why we can break this integral, that is 0 to a e to the power minus st, and this is from less than a, it is less than a, that's why the value of ut minus a will be 0, and next it is a to infinity, and it is greater than a, so that's why the value of ut minus a is 1. Clear? So this integral will be 0, and this part will be integration of e to the power minus st only, so minus 1 by s e to the power minus st, and limit is from a to infinity, and for upper limit this value will be 0, minus for lower limit it will be e to the power minus as, and minus 1 by s is there before, so multiplying minus minus will be positive, so e to the power minus as by s. Okay, so in this way you can derive Laplace transform of ut minus a, and that is your e to the power minus as by s. So we have to remember this. For next problem we can use this formula. Clear? Now we will do one example how to write a given function in terms of unit step function. Suppose f of t is given like this. 2 if p is in between 0 to pi, 0 less than t less than pi, 0 if pi less than t less than 2 pi, and sin t if t greater than 2 pi. So the value of f of t is like this. According to the interval, the values are 2, 0 and sin t. So how to write the given function in terms of unit step function so that we can easily find its Laplace transform. So once we can write the given function in terms of unit step function, then we can write easily the Laplace transform of this function. Okay, so how to write? So first write 2. The value is 2, so 2 into, from this interval, u t minus 0, then u t minus pi, u t minus 0 minus u of t minus pi. So for each interval we have to write u t minus 0, then minus u of t minus pi, right? Similarly, the next value is what? 0. So 0 into plus 0 into u of pi minus t, u of t minus pi, u of t minus pi, then minus u of t minus 2 pi, right? Next value is what? Sin t. So sin t into u of, since it is greater than, means we have to take the value when t greater than 2 pi, the value will be 1. So u of t minus 2 pi will be 1, and the value will be sin t into 1 will be sin t, because we have to take this value. So that's why we have to take u of t minus 2 pi plus sin t into u of t minus 2 pi. Again I will describe this. That is 2 if 0 less than t less than pi. So that's why 2 into u of t minus 0 minus u of t minus pi, 0 into u of t minus pi minus u of t minus 2 pi, then sin t into u of t minus 2 pi, u of t minus 2 pi, right? So if you multiply 2 with this, so 2 into u of t minus 0 means ut only. So 2 into ut minus 2 into ut minus pi. So 2 into ut minus pi, then this value, the whole value is 0 because 0 is multiplied. So whole value is 0. Then only the remaining term is what? Sin t into this. So sin t into ut minus 2 pi. So this function can be written as, are written in terms of unit step function like this: 2 into ut minus 2 into ut minus pi, then plus sin t into ut minus 2 pi. The next is one of the important theorem, that is second shifting theorem. That is second shifting theorem. So which is called also t shifting theorem. Now what is second shifting theorem? That means if Laplace of f of t equal to f of s, okay, Laplace of f of t equal to f of s, then the shifted function Laplace of f of t minus a into ut minus a will be e to the power minus as into f of s, right? So if I write this shifted function, how to write this? F of t minus a, ut minus a, what is the value of this? F of t minus a means we can take this as, because ut minus a is 0 if t less than a and 1 if t greater than a. So this value will be what? It will be 0 if t less than a, and it is ft minus a because the value is 1 when t greater than a. So 1 into f of t minus a will be f of t minus a. So this is the shifted function ft minus a into ut minus a will be like this: 0 if t less than a, and f of t minus a if t greater than a. This is the value of shifted function. Now this shifted Laplace transform of this shifted function will be e to the power minus as into f of s. And if you take inverse on both sides, Laplace inverse on both sides, it will be f of t minus a ut minus a is equal to Laplace inverse e to the power minus as into f of s. Okay, so this is second shifting theorem, statement of the second shifting theorem, or it is called t shifting theorem because t is shifted here. So it is also called t shifting theorem. So using this second shifting theorem, we can also find the Laplace transform of this function. So how to find? So Laplace transform of this example, we can find Laplace transform of what? 2 into ut. So according to linear principle, separately we can take 2 into 2 is constant. So what we can write? 2 into Laplace of ut minus 2 into Laplace of ut minus pi, then plus Laplace of sin t into u of t minus 2 pi, right? So that is equal to 2 into, since Laplace of ut minus a, what is the formula? We have also derived e to the power minus as into s. So since it is ut only, means a equal to 0. So the value will be e to the power 0, means 1. So 1 by s. Right. So 2 into 1 by s minus 2 into Laplace of ut minus pi. So a equal to pi. So e to the power minus pi s divided by s. So Laplace of ut minus pi is 2 into 2 is also there. So 2 into Laplace of ut minus pi means e to the power minus pi s by s. Now plus Laplace of sin t into ut minus pi. So to find this result, we have to use this second shifting theorem because it is multiplied directly. It is not only unit step function, it is multiplied with the function sin t. So how to find this Laplace? How to find this Laplace? So we have to first write in this form f of t minus a into ut minus a. So we write it as Laplace of sin t, because it is 2 pi here. So minus 2 pi plus 2 pi. I just subtract minus 2 pi, subtract 2 pi and add 2 pi. Okay, into u of t minus 2 pi. Now this remains same, plus this result will be what? Plus Laplace of this. So Laplace of sin t minus, because sin t minus 2 pi and 2 pi. So 2 pi plus this 2 pi, sin 2 pi plus t minus 2 pi, let it be theta. So sin 2 pi plus theta. So sin 2 pi plus theta is sin theta. So what we can write? This is sin t minus 2 pi. Sin t minus 2 pi only. So into u of t minus 2 pi. Now we can compare with this second shifting theorem, that is Laplace of sin t minus 2 pi ut minus 2 pi. Sin ut minus 2 pi ut minus 2 pi. So a is 2 pi here and f of t minus a. This is sin t minus 2 pi. So what is f of t here? F of t is sin t, because f of t minus a is sin t minus 2 pi. So since f of t is f of t minus a is sin t minus 2 pi, so f of t is sin t. So to find this Laplace, the value is what? According to this formula, it will be e to the power minus as. So what is a here? 2 pi. So e to the power minus 2 pi s. minus 2 pi s into f of s. F of m means Laplace of f of t. What is f of t here? Sin t, because function is sin t. Sin t minus 2 pi, f of t minus a, because f of t minus a. F of t minus a is sin t minus 2 pi. F of t minus a is sin t minus 2 pi. So f of t is sin t. So Laplace of sin t is 1 by s square plus 1. So according to this formula, Laplace of sin t minus 2 pi into ut minus 2 pi will be what? E to the power minus as. So a is what? 2 pi. So e to the power minus 2 pi s into f of s. So f of s is what? 1 by s square plus 1. Clear? So the final result is Laplace of 2 ut. That means it will be Laplace of this function, Laplace of this f of t is what? 2 into 1 by s, that means 2 by s, then minus 2 into e to the power minus pi s by s, Laplace of ut minus pi, and plus sin t, Laplace of sin t into ut minus 2 pi. From this it will be e to the power minus 2 pi s divided by s square plus 1. Okay, so this is the result. So using your second shifting theorem, you can find this result. Last term, Laplace transform of last term will be found using this second shifting theorem or t shifting theorem, like this. Clear? So thank you all, and again we will meet in the next lecture with a new function and with some new problems. Okay, thank you.